Alright, here's part 2 of section 9.3 on special right triangles. This video is going to cover 30, 60, 90 right triangles. So let's start by reviewing the parts of this right triangle. We've got triangle RMN over here. We see it's a 30, 60, 90. So this would be our right angle over here. So first let's name the shorter leg. And again, if you want to pause at any time to fill in the blanks, and then start the video again to see if you were right, feel free. So the shorter leg here is going to be segment RM. The longer leg then would be segment MN. And how do we know which is the longer leg and which is the shorter leg? So this is a review. We know that the longer leg is opposite the larger angle, and shorter leg is opposite the smaller angle. Okay, so the hypotenuse is going to be the longest side, so it would make sense that it would be opposite the largest angle in the triangle, so that's going to be segment RN. Alright, again, hypotenuse is always opposite the right angle. Okay, so let's discover the special relationship between the three sides of a 30, 60, 90 right triangle. We're going to start with an equilateral triangle and draw an altitude to one side. So let's take a look at this triangle over here, triangle DF, I believe that's an E over here, triangle DFE. So this is an equilateral triangle. All three sides are going to be equal, and then we're going to draw the altitude to one side. So what do we know about the angles of an equilateral triangle? Well, we know that they're all equal. So 180 divided by 3 would give us 60, so I know that this would have to be 60 degrees. This would have to be 60 degrees. This whole angle up at the top would have to be 60. We'll get back to that in a second. So remember, if we draw the altitude to a side of an equilateral triangle, it is also the median. It is also the angle bisector, and it is also the perpendicular bisector. Okay, so knowing that it's all of these things, I know that these two segments have to be congruent, and I know that these two angles up here have to be congruent. And if I know that this angle up at the top is 60, and I know that this altitude is also the angle bisector, I know that this is going to be 30 degrees, and this is going to be 30 degrees. And since this is an altitude, I know that we're going to have two right angles down at the bottom. We'll mark one over there. Alright, so by drawing the altitude to one side of the equilateral triangle, we have created two 30, 60, 90 triangles. Okay, so let's see if we can figure out the relationship between the sides. We're going to start by making the sides of the equilateral triangle length 2. So we're going to let each of these sides be 2, and in a minute you'll see why. So 2 from there to there. So if the sides are length 2, then what are the lengths of DG and EG? Well, if this whole thing is 2, we know the altitude is also the median, so it divides it into two equal parts. So each of those sides would have to be 1. So far in our 30, 60, 90 triangle, I know that the hypotenuse is 2, and this leg, which is the shorter leg, is going to be 1. So let's pull this apart and just look at the left half. So here's triangle DFG, and we already figured out, well, we started with the hypotenuse being 2. Here's my right angle, which means that this side over here would have to be 1. Here's my 60-degree angle, and here's my 30-degree angle. So I know two of the sides, I know it's a right triangle, so I'm going to use the Pythagorean theorem to try and find the length of FG. So I've got FG squared plus 1 squared is equal to 2 squared. So FG squared plus 1 is equal to 4. I'm going to subtract 1 from both sides. Let's continue my work over here. So I get FG squared is equal to 3. Take the square root of both sides, so I have the square root of FG squared here, the square root of 3 over here, and I end up with FG equal to the square root of 3. So now this side here is the square root of 3. So the ratio of the sides, shortest to longest, so I would have short leg was 1, long leg was square root of 3, and the hypotenuse is 2. So no matter what the 30, 60, 90 triangle, how big or how small, the three sides will always be in this ratio.